Hello everyone. So in this video we will be solving a new GFG problem which is Euler circuit in an undirected graph. See, it's a medium level problem. So I will say it's a very easy problem because of this condition. I will tell you why I am saying like this. So before going forward in this video, please make sure that you have liked and subscribe to this channel, and also it's my advice to all of you that please read the problem and try to build up the intuition, then try to do the code. And if you stuck at any point, then see this video, then it will be helpful for you. So let's read the problem statement. So problem is saying that Euclidean path is a path in a graph that visits every edge exactly once. So this is the condition, every edge exactly once, and the Euclidean circuit is an Euclidean path that starts and end on the same vertex. Like if I increase this, yeah, that starts and end of the same vertex. These two are the condition. The like means every node, every edge should be visited, or this path, Euclidean path is that starts and end at the same vertex. Given the number of vertices B and the adjacency list ADJ, denoting the graph, find that there exists a Euler circuit or not. Return one if there exists at least one Eulerian path, else zero. Okay, so this is the main condition. Why this condition is making this question is very easy. So I'll tell you why I'm saying like this. But see, note that given path, given graph is connected. So graph is connected. No node is separate. No node, or I can say edge is separate. Edge नहीं node ही बोल सकते हैं उसको, ठीक है. So let's see this question. If b equals to 4, so edges are like 0 to 1, 0 to 2, 1 to 3, 2 to 3. So 0 to 1, then 0 to 2, then 1 to 3, 1 to 3, and then 2 to 3, then 2 to 3. And if I start from 0, so we have two conditions for Eulerian path. So फर्स्ट कंडीशन इज, मैं जहाँ से भी स्टार्ट कर रहा हूँ, और जैसे मैं जीरो से स्टार्ट कर रहा हूँ, तो अल्टीमेटली जीरो पर ही एंड होना चाहिए. फ्रॉम वेयर आई एम स्टार्टिंग एंड एंडिंग भी वहीं पर ही होनी चाहिए. फर्स्ट कंडीशन इज दिस वन, एंड सेकंड कंडीशन इज लाइक every edge of that graph should be visited, must be visited exactly one time. So these two are conditions. Like, let's see the conditions are matching in this graph or not. So if I start from 0, so I can go from 0 to 1, then 1 to 3, then 3 to 2, then 2 to 0. So मैंने 0 से start किया और मैं 0 पर ही आ गया. First condition is matching, perfect. And you can see I am going from 0 to 1, then 1 to 3, then 3 to 2, then 2 to 0. I am covering all the edges, 0 to 1 edge, then 1 to 3 edge, then 3 to 2 edge, then 2 to 0 edge. So I am covering all the edges. See, it's an undirected graph, so that's why if I will say like 0 to 1 or 1 to 0, it's the same thing. If it will be directed, then it will be like 0 to 1 is not equals to 1 to 0. But here it even undirected graph, so that's why I can say like 0 to 1 or 1 to 0, edge is same. So you can see all edges are visited exactly one time, and if I am starting from 0 and I am ending at the same time, I am ending at the 0 index. So all two conditions are matching, so that's why I will return true. 1 1 is denoting a true. If I see this 0 to 1 edge, then 0 to 2 is 2 edge. If I start from 0, then I can go 0 to 1, but I can't go 1 to any other node. So it is the conditions are not matching because first condition is false. Like if I starting from 0, then 0 to 1 I can go, but 1 से आगे कहीं भी नहीं जा सकता, ठीक है. So start and end, but ending index same नहीं है, that's why I return false 0. So let's see the approach part for this. So this is the definition, like a trail which starts and ends at the same vertex is called Euler circuit. All the edges should be covered first, like exactly one time. All the edges should be visited exactly one time. So let's see some example for this. So this is the graph. If I start from 0, then I can go 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4, then 4 to 2, then 2 to again 0. So I am starting from 0 and ending at 0. So first condition is matching, and the second condition is all nodes of that graph should be visited, must be visited exactly one time. So I am visiting all the nodes like 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4, then 4 to 2, then 2 to 0. So all the edges of the graph are visited. So that's why I can say like all two conditions are matching for the Eulerian path. So it is a Euler circuit. If I see in this graph, like if I am starting from 0, so I can go 0 to 1, then 1 to 3, then 3 to 2, then 2 to 4, then 4 to 0. But you can see I am starting from 0 and I am ending at 0. First condition is matching. But you can see here 0 to 1, 1 to 2, 1 to 3, sorry, then 3 to 4, then 4. If I go like 0 to 1, then 1 to 3, then 3 to 2, then 2 to 4, then 4 to 0. You can see that 3 to 4 node is not visiting. Like if I take any path, if I will take any path, one edge will be there that is not visiting. So that's why I can say it is not a Euler path because our second condition is not correct here. Here is not matching that second condition. This graph is not matching that condition. So if I start from here 0 in this graph, I can go 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4, then 4 to 2. So I am starting from here and I am ending at here. So first condition is not correct here. For first condition is not applicable actually in this graph, so I can say it is not a Euler. It is the important example for this. If I start from 0, then 0 to 1 I can go, then 1 to 2 I can go, then 2 to 0 I can go. So first condition is starting and ending point should be same. So start यहाँ पे कर रहे हैं, end भी यहाँ पे कर रहे हैं, तो first condition is correct. And the second condition is all the edges of that graph must be visited exactly one time. So edges are 0 to 1, 1 to 2, then 2 to 0. So all the edges are visited. However, there are some nodes like 3 and 4. For for this, the degree of 3 is 0, degree of 4 is 0. There are no edges between them. So degree what is the degree? Degree is how many nodes are connecting with how many nodes are connecting through that. Like I will say like degree of 0 is here 2 because 1 and 2, two edges are connected. How two edges or I can say two nodes are connected because these are two edges or these are two nodes. If I will say like what is the degree of 1 here, so degree of 1 will be 2 because two edges are connected to this 1. So this is the Euler because first condition and second condition both condition are matching in this graph. So in this example, you can see if I start from 0, then 0 to 1, then 1 to 2, then 2 to 3, 0. First condition is matching, but you can see here, first condition is matching, and I am visiting all the node edges here, but I am not visiting all the edges here because if I am starting from here, then I can go 0 to 1, 1 to 2, then 2 to 0, but I didn't cover this edge 3 to 4. 3 to 4 is the edge that I didn't cover. So second condition is not matching here. So that's why it is not a Euler circuit. So now I know like what is Euler path and what is Euler circuit. There are two conditions like first condition is start node equals to end node and the second condition is every edge must be visited only once, means one time that node is visited, that edge is visited. So see, it's an undirected graph, so that there is a condition like all vertices should have even degree. By even degree, I will say like you can see here the degree is zero. Degree is zero. If I, because it's an undirected graph, so 0 to 1 and 1 to 0. For what the nodes, the edge is same because 0 to 1 I can say this is the edge. For 1 to 0 I can say this is the edge. So I will say like z if I will see the degree of 0, then that will be the 2. So like I can say for the undirected graph that all the vertices should have the even degree. So this is the main condition for this. So let's see, yeah. So let's see the algorithm for this, and I will apply this algorithm for this x graph like 1, 2, and 3. And there is another edge like out of the graph, zeroth edge. The edge, no, 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 yeah. So algorithm is very simple. Like firstly, I have to find a node with a degree greater than zero. Why I'm telling degree greater than zero? Because you can see here, here degree is zero, here degree is zero. If degree is zero, it means there is no edge. If there is no edge, then I can directly say, yeah, like that is not contributing a part in my graph because degree is zero. So I, first condition and second condition will not affect on this edge. Like if degree is zero, then this will not affect on my condition. So I'll say like first I'll find the degree greater than zero. So degree is 2, degree is 2, degree is 2, degree is 0 here in this graph. Now I'll check if number of nodes found, then Euler graph. No node found, sorry, number color. If no node found, then Euler graph. Like else do FDFS and mark all nodes in component and check if any node with a degree greater than 0 was unvisited. If true, not Euler graph. I'll tell you what is the final theme of this. So what I will do, I will create a visited array and I will check initially visited array, all the nodes, all the blocks will be initialized as false. And now I'll check like if I'm at the, if a degree of this one is greater than 0, so this is true. Degree of 2 is greater than 0, this is true. Degree of 3 is greater than 0, this is true. And degree of 0 is greater than 0, no. Degree of 0 equals to 0, so this is also false because I will not change this. I will change like if degree is greater than 0, then I will convert this false to true. And now I'll check, yeah, key degree, but this will not affect on my graph because degree is 0. There is no edge. Our conditions are like all the nodes should, the first condition was if I am starting from this index, I will end up all, I will end like end pointer should be on that index. Same index should be there. In my starting node should be equals to ending node. And the second condition was all the nodes of that graph should be visited, must be visited exactly one time. So all the nodes of this graph exactly visited exactly one time. And like you can see if I start from 1, then 1 to 2, then 2 to 3, then 3 to 1. So starting node and ending node are same. So I can say this is a Euler graph. But I have to check. Now second condition comes in picture, like I'll check like count of odd degree nodes. If there is a count which is odd degree, like odd degree, like I can say if I told you about this key. This is the main condition for this. All vertices should have even degree. Agar because it is an undirected graph, so all vertices should have even degree for this Euler path. These three are the main conditions. But I have discussed about these two conditions and I told you about this कि ये कंडीशन है कि अनडायरेक्टेड ग्राफ के लिए all vertices should have even degree. If now this is the case, now I'll check if कोई vertices की degree और तो नहीं है, so count of odd degree nodes, I will count the all the odd degree nodes. Like if count of odd degree nodes is 0, so I can directly say it's a Euler graph. If count of odd degree nodes is 0, like you can see here, degree is 0, degree is 2. There is no single count of odd degree. Like count of odd degree is here is 0 in this graph. So I can say count equals to 0, then it is a Euler graph. If count equals to 2, that is semi-Eulerian graph. However, this question only wants Eulerian path, but I will tell you like what is semi-Eulerian path. Semi-Eulerian path is count equals to 2, then semi-Eulerian path, and count is greater than 2, then not Eulerian path. So that is the algorithm. But you can see here why I was telling like this is very simple question because of this single line. Note that given graph is connected. You can see your given graph is connected means there will be no single edge, no single node. Like here, there is a single node. That's why I'm checking this condition like if degree is greater than 0, degree is greater than 0 or not, degree is greater than 0 or not. But you can see here the graph is connected. So if the graph is connected, so there will not be any single node that degree is 0 because all the graph is connected. So and it is an undirected graph, so the graph, the degree of any node will be greater than equals to 0. So there will not be any single node that degree is 0. So this condition, no, I will not check this condition, I'll check only this condition. If the count of odd degree nodes is there or not, means greater than 0, equals to 0, or equals to 2, I'll check this count. बस count of odd degree nodes check करूंगा. If there is a count of odd degree node which is 0, count equals to 0, then I will say like it is a Euler graph, and else condition I will directly say like it is not a Euler graph. So this was the complete algorithm for this question. Now I'll write the code for this. The coding part is very simple. I'll say like 4 to 5 line code. It is there. So what I will do, I'll count odd count. Initially it is odd count is 0. Now I will apply a loop for int I equals to 0 to I less than b, then I plus plus. And now I will check if adjacency जो list है मेरी, adjacency list of I of 0 I can say. So adjacency जो list है ये वाली list you can see here, जो adjacency list बनाई हुई है 0 1 0 2 1 3 2 3, तो adjacency list of I, sorry, dot size, इसका जो साइज है, जो इसका साइज कितना है, इसका एडजेसेंसी लिस्ट ऑफ 0 का साइज कितना है 2, 1 का साइज कितना है 2, अगेन एडजेसेंसी लिस्ट ऑफ 2 का साइज कितना है 2. सो इसका मॉड्यूलो 2 is not equal to 0. It means that size is odd. It means the size is odd. It means I will increase the odd count, because that also equals to the degree that is representing the degree. You can see here, if I will say like 0 to 1, 0 to 1, so there is an edge between this. So I can say the degree is how many nodes are connected with, like this. If I will say this, I'll see this 0th node. So how many edges are connected through that? So 1 and 2, two edges are connected. So degree is equal to 2. So that's why I will say like odd count plus plus. And now I'll check like ऑड काउंट और ऑड डिग्री बोल सकते हैं, मैंने ऑड काउंट बोला है, ठीक है. आई विल चेक लाइक इफ ऑड काउंट equals to 0. In this case I will return 1 means true, and in else case what I will return, I'll return false, or we can say 0. So let's run this code and see if this will work or not. Yeah, it is working perfect. Let's submit this code. Yeah, you can see here it is working perfect. So this was a simple algorithm for this. Because of this line, this code is very simple. And you can see here what I have done is I am finding the odd number of count, odd degree count. It is, if I write the comment here, odd degree, sorry, count. So here I am finding out the odd degree counts, like how many odd degree counts are there. So I will increase that count, and if I will check like odd degree count equals to 0, if there are all vertices that degree, the all the vertices that have a degree equals to 0, means that at a degree even degree, like this condition is matching, like you can see all vertices should have the even degree. If all vertices should have the even degree, means the odd count equals to 0. In that case, I will return true, otherwise I will return false. So this was the simple code. If you find this helpful, then please like, share and subscribe. तब तक के लिए bye. मिलते हैं next week.